Hey, so let's talk about one of the most misunderstood forces in all of physics, friction. Yeah, you think you know how it works, but I promise by the end of this, you're going to see it in a completely new and way more accurate light. All right, let's kick things off with a classic textbook problem. You're pushing a heavy crate across the floor. You're pushing it to the right. The question seems simple enough, right? Which way is the force of friction pointing?
You probably just said to the left, didn't you? And look, for this specific case, you're not wrong. But what if I told you that simple answer is the number one reason people get friction problems wrong?
Yeah, that's because the whole idea that friction just opposes whatever direction you're pushing is a massive oversimplification. It's a myth, really, and we are about to bust it wide open because relying on it will lead you straight to the wrong answer almost every time. I get it. It feels intuitive and it works for that simple little crate example. But the second things get more interesting, that rule is going to fail you. We need something better, a rule that's more powerful and, actually correct. So let's get to the real story. Friction isn't about opposing you or your push or your effort. It has one job, and one job only, to oppose relative motion between surfaces. That's it. And what in the world is relative motion? It's just a fancy way of saying how one surface is sliding or trying to slide across another. Just rub your hands together real quick. That sliding is relative motion. It's all about what's happening right there at the surface. And this brings us to the golden rule. Seriously, if you remember one thing from this whole explainer, make it this. Friction opposes the slide. Or, and this is the important part, the attempted slide. That word tendency, that's the secret ingredient. It is the key that unlocks every single friction problem you'll ever face. Now, to use our new rule, we need the right tools for the job. See, friction isn't just one thing. It comes in two main flavors that act very, very differently. We're talking about static and kinetic friction. Let's break this down. First up, you've got static friction. Think of this as the stubborn one. It's the force that really digs in to stop things from sliding in the first place. It's kind of smart, too. It only pushes back as hard as it needs to, up to a certain limit. But once that object starts sliding, bam, kinetic friction takes over. It's weaker than static friction, but it's always there fighting against the sliding motion. Okay, we've got our golden rule, we've got our two types of friction. Now, let's have some fun and put them to the test with a couple of scenarios where that old opposite the push myth just completely falls apart. Let's start with something you literally do every single day, walking. You probably don't think about it much, but friction is the only reason you can move at all. Okay, think about the mechanics of taking a step. To move yourself forward, your shoe grips the ground and actually pushes the earth backward. So what is the tendency of motion for your shoe against the ground? It's trying to slip backward, right? And here's the big reveal. To oppose that backward slip, static friction has to push your foot forward. Just let that sink in for a second. The force of friction isn't slowing you down. It is literally the force that is pushing you forward and making you walk. All right, let's try another classic physics puzzle. Picture a cardboard box just sitting on the flatbed of a truck. The truck is stopped, but then the driver hits the gas and starts accelerating forward. So the truck is accelerating to the right, and that box is coming along for the ride. It's not slipping around. So which way is the force of static friction pushing on the box to keep it in place? The answer is to the right, the same direction the truck is accelerating. Why? Well, it's all about inertia. The box, being a lazy object, wants to stay right where it was. So as the truck bed moves forward underneath it, the box has a tendency to slip backward relative to that truck. And what does static friction do? It opposes that tendency, so it has to push the box forward, which is what makes it accelerate with the truck. So you might be thinking, okay, that's a cool little physics trick, but why is this so important? Well, because getting this one detail right is absolutely fundamental to basically all of mechanics. Here's the deal. If you get the direction of friction wrong, your entire problem collapses. Your free body diagram? Wrong. Your F equals ma calculation? Totally wrong. Everything from figuring out how a car turns a corner to analyzing a block on a ramp depends on you mastering this one simple idea. So, I'll leave you with a final thought. We always think of friction as this annoying force that slows things down and wears stuff out. But as we've just seen, it's also the force that gets us moving in the first place. So, can you think of any other machines, big or small, that would be completely useless without it? Something to think about. Thanks for tuning in.